A black hole that hasn't eaten anything in millions of years just exhaled, and the breath was 36 million degrees. That is not a metaphor. An X-ray telescope just detected a massive burst of superheated plasma erupting from a black hole that was supposed to be dormant. And it is rewriting what we thought we knew about how black holes behave when they are not actively feeding. The detection was made by JAXA's XRISM spacecraft, the X-ray imaging and spectroscopy mission, which launched on September 6, 2023, from the Tanegashima Space Center in Japan. XRISM carries the most sensitive X-ray spectrometer ever placed in orbit, Resolve, a microcalorimeter that measures X-ray photon energies with a precision 30 times greater than any previous instrument. To function, Resolve operates at just 50 millikelvins, 0.05 degrees above absolute zero, making it one of the coldest operating instruments in space. In early 2025, XRISM turned its instruments toward NGC 4151, a Seyfert galaxy roughly 62 million light-years away in the constellation Canes-Venatici. At its center sits a supermassive black hole with an estimated mass of approximately 40 million times the mass of our Sun. This black hole has been studied for decades. It was considered to be in a relatively low-activity state, not fully quiescent, but not actively consuming large amounts of material either. What XRISM detected was extraordinary. A massive outflow of plasma at a temperature of approximately 36 million degrees Celsius, 20 million Kelvin, erupting outward from the region immediately surrounding the black hole at velocities exceeding 1,000 kilometers per second. The spectral resolution of Resolve allowed the team to identify individual iron emission lines in the X-ray spectrum with unprecedented clarity, revealing the precise temperature, density, and velocity structure of the outflow in detail that has never been possible before. This kind of outflow is called a warm absorber, or hot wind, depending on its temperature and ionization state. It originates not from inside the black hole. Nothing escapes from within the event horizon, but from the accretion disk and corona, the superheated material spiraling around the black hole before crossing the point of no return. Even when a black hole is not actively consuming large quantities of gas, residual material in the accretion region can still produce powerful outflows. What makes this detection scientifically significant is not simply that the outflow exists. We have known that active galactic nuclei produce winds. It is the level of detail XRISM captured. Previous X-ray observatories like Chandra and XMM Newton could detect that outflows were present, but they could not resolve the fine spectral features needed to determine exactly how hot the gas was, how fast it was moving, or precisely what elements were present. XRISM's Resolve instrument changes that completely. The 36 million degree temperature measurement is critical because it places the outflow in a specific physical regime, hot enough to be driven by magnetic processes in the corona rather than by radiation pressure from the accretion disk. That distinction matters for understanding how energy transfers from a black hole's environment back into the surrounding galaxy. These winds carry enormous amounts of energy outward, heating and pushing gas in the host galaxy, potentially suppressing or triggering star formation across distances of thousands of light-years. This process, called AGN feedback, is one of the most important and least understood mechanisms in galaxy evolution. It is the primary way supermassive black holes regulate the growth of their host galaxies. Without feedback, simulations predict galaxies would form far more stars than we actually observe. The energy carried by these hot winds is one of the leading candidates for what provides that regulation. XRISM is still in its early science phase. The mission is designed to operate for at least 3 years, observing supernova remnants, galaxy clusters, neutron stars, and additional active galactic nuclei with the same spectral precision. Each observation has the potential to reveal physical processes that were previously invisible to cruder instruments. Follow for more on the instruments revealing what we could never see before. And tell me, if a supposedly dormant black hole can exhale plasma at 36 million degrees, does dormant really mean what we thought it meant?